Hi students, this is Alex here. In this video, they have given if a string of length L is initially at rest in equilibrium position, each of its point is given by the velocity v0 sine cube pi x by L and x ranging from 0 to L. We have to find the displacement of a point at a distance x from one end at a time t. Let's write the initial conditions and boundary conditions. So the first condition is y of 0 comma t is 0, that is displacement at one end is 0 for all values of t. Similarly, the displacement at the other end, that is L comma t, is also 0 for all values of t greater than 0, and it is in the equilibrium position initially. So y of x comma 0 is 0 for all x ranging from 0 to L, and it is given an initial velocity. So dou y by dou t of x comma 0 is v0 sine cube pi x by L. So these are the conditions we have. Now we are going to write the wave equation. So the wave equation is, we have the wave equation dou square y by dou t square equal to a square into dou square y by dou x square. So this is a wave equation. We have a suitable solution. Let's write that. The suitable solution is y of x comma t is c1 cos px plus c2 sin px into c3 cos pat plus c4 sin pat. Now using the first condition, which is y of 0 comma t is 0. So wherever x is there, we have to replace it with 0. So I'm going to replace 0 here. So y of 0 comma t is c1 cos 0 is 1 and sin 0 is 0. So we have only c1 left, and rest of the terms is written as it is. c3 cos pat plus c4 sin pat, and this value is 0. So 0 equal to c1 into c3 cos pat plus c4 sin pat. Now c1 will be 0 because c3 cos pat plus c4 sin pat cannot be 0 as it is defined for all t. Therefore, the only option is c1 equal to 0. Now we are going to replace c1 0 in our solution. So y of x comma t will be, once c1 is 0, this term will not be there. So we have only c2 sin px into c3 cos pat plus c4 sin pat. Now using the second condition, which is y of L comma t is 0. So wherever x is there, we have to substitute L. So y of L comma t equal to c2 sin pl into c3 cos pat plus c4 sin pat. Now this value is 0. So 0 equal to c2 sin pl into c3 cos pat plus c4 sin pat. Now already we discussed c3 cos pat plus c4 sin pat not possible to be 0 because it exists for all the values of t, that is, it defined for all the values of t. Similarly, c2 not equal to 0 because already c1 is 0. So again c2 cannot be 0 from the same term. So the only solution is sin PL is equal to 0, which implies when sin theta equal to 0, we have theta is equal to n pi as the solution. So here PL is like theta. So PL equal to n pi. From this, P is n pi by L. So we are going to substitute this in our solution. Y of x comma t equal to C2 sin px. So instead of P, we have to write n pi by Lx into C3 cos PAT, n pi by L AT plus C4 sin PAT, so sin n pi by L AT. Now we are going to use the third condition. The third condition is y of x comma 0 is 0. So wherever t is there, we have to put 0. So y of x comma 0 equal to C2 sin n pi x by L into cos 0 is 1. So only C3 is left, sin 0 is 0. So totally C3 is left and this value is 0. So 0 equal to C2 sin n pi x by L into C3, and here already we discussed C2 cannot be 0 and sin n pi x by L cannot be 0 because it is defined for all x, and therefore the only option is C3 must be 0. So using C3 as 0, again we are going to get the solution, that is y of x comma t will be C2 sin n pi x by L, and since C3 is 0, we have only C4 sin n pi by L AT. Now we are going to combine both the constant C2 and C4 as a single constant Cn, and we have sin n pi x by L into sin n pi by L AT. This is y of x comma t. Now we are going to use a fourth condition. For that we need its derivative. So dou y by dou t at x comma t will be constant, we keep as it is. Cn is a constant and x term is a constant. Sin pi x by L we keep as it is because we are doing partial derivative with respect to t, and this becomes cos n pi by L AT into t coefficient is n pi by L into a. And now as per the condition, that is the fourth condition, we have dou y by dou t of x comma 0. So let's take t as 0. So dou y by dou t of x comma 0 will be, and Cn we have, and we have to put t as 0. So this term will become 1. We can also take the summation here. N is from 1 to infinity. Even here, when we have constant and other terms, we take n is from 1 to infinity. And now this will become summation from n is equal to 1 to infinity Cn into sin n pi x by L into n pi a by L, because this term becomes 1 when t is 0. And here dou y by dou t of x comma 0 is given as v naught sin cube pi x by L. So this is v naught sin cube pi x by L is this, n is equal to 1 to infinity. We have Cn sin n pi x by L into n pi a by L. Now I am going to take this Cn and n pi by L into a together as Bn. So let Bn equal to Cn into n pi a by L. So this becomes v naught sin cube pi x by L equal to summation n is from 1 to infinity bn. Then we have sin n pi x by L. Now we are going to use a basic trigonometric formula. Sin 3x is 3 sin x minus 4 sin cube x. So we take this term here and the sin 3x to the other side. So 4 sin cube x will be 3 sin x minus sin 3x. So sin cube x will be 3 by 4 sin x minus 1 by 4 sin 3x. So here we are going to replace this formula. So V0 into 3 by 4 sin pi x by L minus 1 by 4 sin 3 pi x by L. So I replace sin cube formula, but in place of x we have pi x by L. So I have to substitute correctly. And on the other side we have summation. Let's expand the summation. Now when I take n as 1, I get b1, then sin 1 pi x by L. Then when I take it as 2, I get b2 sin 2 pi x by L. When I take it as 3, then b3 into sin 3 pi x by L. When I take it as 4, b4 into sin 4 pi x by L dot dot dot. Now by comparison, here we have sin pi x by L, here we have sin pi x by L, and this coefficient is 3 by 4 V0 will be equal to B1. Then this B2 will be 0 because we don't have sin 2 pi x by L here. Then coming to sin 3 pi x by L, we have it here. From this we can get B3 as V0 by 4 with a minus sign. And after this B4, B5 dot dot dot, all the terms are 0. So we have only B1 and B3. So these two we have. So now we can find C1 and C3 from this. So 3 V0 by 4 is B1, but what is the relation between B1 and C1? So we have to take from here. So in place of this B1, I can put C1 n pi A by L. So this is C1 into n pi A by L. Similarly, B3 is C3 n pi A by L, which is minus V0 by 4. So we get C1 as this L n pi by A will go to the other side. So it is 3 V0 L by 4 n pi A. And in this case n is 1. So we don't write n here because n is 1. Similarly, here n is 3. So from this C3 will be minus V0 by 4 and L will go here into 3 pi A in the denominator. So finally we got C3 as minus V0 L by 12 pi A. So these things we are going to substitute in our solution. This is our solution. But the summation we should write it in the expanded form. So y of x comma t equal to when n is 1, we get C1 sin pi x by L sin pi at by L. So C1 sin pi x by L, because n is 1, then sin pi at by L, plus C2 sin 2 pi x by L into sin 2 pi AT by L plus C3 sin 3 pi x by L into sin 3 pi AT by L dot dot dot. But this value of constant exists only for C1 and C3. Rest of the constants are 0. So by substituting this is 3 V naught L by 4 pi A into sin pi x by L into sin pi AT by L. C2 is 0. Then C3 will be minus V naught L by 12 pi A into sin 3 pi x by L into sin 3 pi AT by L. This is our required complete solution for the given problem.